Hello everyone, welcome to my channel. Today I will be talking about how to create a new file in code variable program in order to have half of your code or whatever you want to write down in that file and kind of connect it to our main code in our main file, so you can have them separately instead of having them all in one file. That's gonna be really helpful when you have like around 2000 line of code and you want to separate them, or you have different functions that you want to use and you want to have just separate file for different part of your code. This can be really helpful. So very first thing that you need to know is that you need to know how to create that file so you can add it to your source file. First, you're gonna go to your file. Let me maximize these. Okay, you're gonna go to file, then you're gonna have your new text file, or you can hit Control N on your keyboard. You don't need to write down anything at the beginning. What you need to do, you need to save this file in the same location that your the rest of your code has been saved. For example, here mine is in my document, and I saved it in project 2. So you're gonna go there, then you need to know where you actually saved it. Once you are here, you're gonna go to your sources file folder, and then I recommend choose a name that you want that file actually like do. I use, if you know how like MATLAB works, for example, if you have two separate files that you want to connect them together, you want to keep that name all the way through the program. This might not be necessary, but it's gonna help like removing any errors that might happen. So, for example, I want to make a delay file. I want to make a delay in this folder, and I want to save it here. So I'm gonna save it as a delay. What is important here, whatever the name you want to pick, that's your choice. But the thing is that you have to write down the name, then you're gonna put dot, and then you're gonna write down ASM, which that's what type of file that your main file that actually can read, or code variable can read. You can write down dot C in case you have C code, but since we don't have a C or C++ coding, we're just gonna write down ASM. So then you're gonna save it. So now you see that it's all different, but still we're not done, because as you see, you can see that source here. What you're gonna go click on the source and double click on it, and then you're gonna add files to it. Since I'm already there, then you're gonna have to go to the same location to the source, and then you're gonna click on the file you created before and then hit open. Now these two files are a part of your code. In order to write the delay code, or if you want to put the delay in that file, this is what you're going to do. If you remember last time we talked about coding, we write down a delay code in our program. What I want to do, I want to write down my delay code in another file. Basically, you need to copy and paste that in your file, uh, and guess I didn't copy it. Control C, and then Control V at this point. So, but if you try to run this, it won't read this part of your file, because right now you have a delay here, but beside that you have actually delay. There's no way that this code is gonna go to the second file that we just created. In order to do that, I'm gonna remove this delay, and wherever you want in your program that delay works, you're gonna use the instruction of JSR, which is basically jump to that subroutine. It's basically a subroutine that you are creating. If you are in the class, or if you're student, you're gonna get to this point at what time of your class time, and then your instructor is gonna explain the subroutine, and this is basically how you create in a subroutine somewhere else in your program. Just let you know, your subroutine it's not something that specific that has to be in a separate file. It actually can be just here. You can have JSR here, and then you can have the same code somewhere else down in your the main file. So that the part of creating the code, the file is not the part of subroutine. Subroutine is using that JSR. So we're gonna use JSR delay, which delay is our actual delay here. But since we have it two times, I'm gonna call it delay one. So then at this point, we're gonna call this delay one as well. It's basically a jump or kind of like branch that branches to this point of the code. But you need to make sure that when you do that, it's actually gonna come back from there. So when you do JSR, you're gonna write down RTS at this point. So this way, when you go to this part of your code, then it will be able to jump back to here and then do the rest of the code. Otherwise, it's just gonna go there and never is gonna come back from this file. This is same if you write down the same thing. If you just copy the whole thing, and if you write it down at this point, that's basically the same thing. So it's gonna write it down there. So keep in mind that might be the case. So this is really good, but we're still not done because if you try to run it again at this point, you're gonna get error that where is this delay one? Because since it's another file, it can't find it. We need to make a connection between this file, the delay file, and our main file. So basically, you need to use the xdef and xreference, which means if you define something here, you need to reference it somewhere else in your code. In here, we're gonna uh, write down xdef, and since here we're gonna uh, define the delay one, we're gonna write down delay one here, and then at this point, since this one referencing to that file, we're gonna write down delay one as well. So this way, this file reference from here, which is here, and then you can actually read the number. So let's see what's gonna happen. So we're in our debugging part of our code. We're gonna see what's gonna happen at the JSR. When you hit JSR, it's gonna go somewhere else. Since you can see it at this point, you're gonna double click on here, and then you're gonna go to open source file, and you're gonna hit delay. So now you will be able to see the delay part, and then it's gonna be do the delay. So, uh, as you saw, you can really see what's happening in the JSR since I'm using the simulation of the simulation part of the program. Now, I don't have the actual board in front of me. Otherwise, I would be able to see the JSR delay one automatically. So, to fix that, there is another instruction that we can use. But in order to do the JSR, you are doing it predefined. If you use the JSR here and use the RTS, program gonna work perfectly fine. The only thing that you can do to actually see this JSR, instead of using the JSR, you can use the call function. That's basically same. It's just gonna let you see the code, and instead of using RTS, you have to use RTC to come back to this part, to this line of the code again. So now when we debug it, it's gonna we're gonna step through it. So when you use the call, it's gonna go to that location. Now you can actually automatically basically see it. This is just bypassing the having the actual board, but it still is not perfect since it's not what we want to do, and also we can see the whole thing, and it's also not coming back for whatever reason. So now we have our delay, and then uh, you made the delay. We're gonna do the RTC. Let's try something. Let's see if we change our source file and go to the main and see if it's gonna actually show it to us that where is it going. I'm not really sure. I don't think so. No, it's not the code I want to see. Anyway, so that's that. What it's gonna do at this point is just gonna come back to this line of code and read the rest of it. So in order to do that the right way, we're just gonna write down JSR, and then we're gonna use RTS. Something here that it's really important that when you're using like accumulators in your subroutines, since it's using the stack pointer to point at this line of the code, it's really important that when it's coming here, it's actually coming back to the code as well. This gonna work for like really small codes, but once you have a lot of line of codes that's happening here, you want to have your registers to keep the numbers that or the values that they had here. For example, if you had accumulator A with number one or whatever is happening in it, you want to have it saved somewhere. So there's two ways that you can do it. You can save it in something like a storage that you can actually save it, or you can use push and pull function in your code so you can actually see what's happening. So uh, in order to do that, you're gonna write down uh, PSHA, which is push A, and then PSHB, and then PSH Y, and PSH X. So you want these four accumulators goes and come back with the same numbers. You don't want it to change. So what you're gonna do that these numbers gonna actually save the accumulator, and then you want to pull them back, which is gonna be pull uh, X, and then pull Y, and pull B, and pull A. So if you notice, I wrote them in the exact back order. Like if you have A, B, Y, X, at this point when you pull, you have to do X, Y, B, A. This way, they're gonna be in the right place. And uh, I don't think you can actually see it at this point in the code debugging part of the code, but let's try it. So yeah, then if you want to do that, you have to use the call function. So everyone, that's said, if you have any question that you want me to answer, you can write down your question in the comment section, and I'll make sure I get to those questions as well. If you like my videos and like my page, you can go ahead and subscribe and like my videos or share them with other students so they can use it as well. Thanks for watching. That's it.